Welcome to the debate. Our focus today is on a really fascinating topic, emotional artificial intelligence, or EI, or emotion AI. These are the systems designed to recognize, interpret, and respond to human emotions using cues like facial expressions, your tone of voice, even body language.
Right, and this all falls under the academic umbrella of affective computing. It's arguably one of the most consequential and definitely most controversial areas of AI development right now, just given how intimately it deals with human feeling.
Absolutely, and that brings us to our central question. Is the current state of emotion AI, a genuinely beneficial and scalable technological revolution, or are its, fundamental technical limits and the very serious ethical risks just too great to justify this widespread rollout we're starting to see? My position is that the proof is really in the outcomes. The technology has achieved significant clinical validation and is delivering real, measurable value, which to me confirms its growing reliability and its positive impact.
And that's a very optimistic take. I come in it from a slightly different angle. I believe the intrinsic difficulty in correctly classifying something as subjective as human emotion, compounded by some deep systemic flaws in the data and just profound risks in how it's used, fundamentally undermines this supposed reliability. I think it threatens really core concepts like user trust and autonomy.
I do see the inherent technical challenges you're pointing to, but let me offer a perspective that's more rooted in its practical success. EAI has matured far beyond just research papers. It's now built on this really robust technical groundwork, which it started with systems like Paul Ekman's facial action coding system, FACS, which defines the 40 specific muscle movements in the face. Companies have now taken that science and integrated computer vision and machine learning to analyze these micro-expressions in real time.
That technical foundation is necessary, I'll grant you that. But it does rely on an assumption of universal emotional expression, which is exactly where I think the technical reliability starts to fall apart.
But the evidence for its reliability is right there in the application. Just take healthcare, a very high-stakes field. There's a clinical AI, a system called Limbic, that operates as a certified Class II medical device for diagnostic support. So this isn't theoretical. It's reporting concrete metrics like doubling patient recovery rates and cutting patient dropout rates by 23%. And maybe most critically, it does this while being 10 times more cost-effective than traditional human therapy. So this really suggests the value isn't just in spotting distress, it's in massively expanding access to care.
Those metrics are certainly compelling, but they feel a bit like selective data points that are masking a more fundamental scientific problem. And that is that the accurate identification of emotion is just inherently unreliable in practice. We are constantly seeing tests that demonstrate frankly low hit rates for telling the difference between key negative emotions, things like disgust, anger, fear, and sadness.
So why is that specific group of emotions so difficult for a machine to tell apart?
Well, it comes down to the underlying science, really, specifically models like Russell's circumplex model. What it shows is that negative emotions like anger and fear are located really close together, consecutively in what's called quadrant 2, and they often share very similar physiological activation patterns. It's not a trivial task for an automated system to draw accurate distinctions between them, and that leads to routine misclassification.
And that misclassification, if I'm following you, is then compounded by what you'd call a generalization failure?
Exactly. Most of these systems are trained on these huge data sets that are just overwhelmingly dominated by Western expressions and cultural norms. So the result is this systemic bias, this generalization failure, where the AI misinterprets or, even worse, stereotypes emotional expressions from other cultural groups. If you can't accurately read the input, the output, whether that's a clinical assessment or a safety warning in a car, is dangerously flawed. It just reinforces systemic inequality. And then finally, even when it kind of works, we hit this authenticity crisis. When AI tries to simulate empathy, users, they remain profoundly skeptical. If the AI tries a little too hard to seem human, it triggers what's called the uncanny valley of mind, which causes discomfort, mistrust, and people just emotionally disengage because their expectation of a genuine connection is violated. So let's really focus on that technical unreliability, especially in these critical uses. I mean, how can AI be considered robust enough for high-stakes applications, say in healthcare triage, or for monitoring driver fatigue in a car, when the underlying models demonstrably struggle to tell the difference between these fundamental, overlapping negative emotions? That low hit rate creates misclassification risks that are, well, they're simply unacceptable when human safety is on the line.
I absolutely acknowledge the physiological overlap between those emotional states is a genuine technical hurdle. I do. But this challenge should be driving us towards more methodological sophistication, not to abandon the technology. And we are seeing progress that's specifically designed to overcome this kind of signal confusion. Newer dialogue models, often inspired by how a human might, think twice before reacting, are showing that emotional refinement can actually be separated from semantic generation in a two-stage process. This helps ensure the right emotional expression is generated based on an empathy hypothesis of the context rather than a raw and potentially confused signal.
But that two-stage model is still just a refinement on the output, isn't it? It doesn't actually fix the biased input data that causes the initial generalization failure. If the system can't reliably read non-Western emotional cues in the first place, that refinement layer is just making an incorrect assumption sound a little more polite.
I disagree that it's just a refinement. The commitment to rigor is actually increasing the accuracy of the input itself. And what's more, leading EAI companies are addressing these generalization challenges by going through rigorous clinical trials and securing medical device certifications. That Class 2 status for products used as intake and triage agents in patient workflows, that proves efficacy in real-world, highly diverse settings. This kind of clinical rigor inherently forces developers to build models that actually do generalize and perform accurately across multimodal contexts, far beyond just spotting a smile. And let's turn now to the immense benefits of scale. The economic and the access benefits of EAI are just so compelling, especially when you look at the surging global demand for mental health support that, frankly, the human workforce simply cannot handle. AII provides necessary support like cognitive behavioral therapy tools at a cost that is 10 times lower and with 24/7 accessibility. This capability meets a demand that human resources just can't reach.
I see why you emphasize that accessibility, I do. But I don't buy that the sheer rush to scale justifies the cost to authenticity and user trust. Studies consistently show that while users might appreciate the availability of EAI, they also frequently report these profound emotional letdowns. The terms they use are things like disillusionment and betrayal, which happens when the AI's emotional depth just isn't there, or when it falls back on generic scripted replies.
But that sounds more like a failure of poor design and mismanaged user expectations, not a failure of the underlying technology's capability to deliver care.
But the inability to deliver genuine empathy is an inherent design limitation. It is. And attempts to increase engagement by making these agents seem overly human-like, they frequently backfire. It's precisely because they trigger that uncanny valley of mind we talked about, making the user suspicious and causing them to emotionally pull back. This just underscores why transparency is so vital. The emotional value people get from EAI is symbolic. It's co-created with the user. It isn't inherent to the machine's own capabilities. We absolutely need clear disclosure that the interaction is with an AI to manage expectations and preserve what little trust might exist.
And following on that point about trust, the ultimate constraint here is the potential for manipulation and the erosion of autonomy. I mean, advanced EAI systems that can precisely understand and predict emotional states present massive leverage points.
We're talking about using this tech to create hyper-personalized, persuasive campaigns that exploit known vulnerabilities in advertising or even political messaging by targeting emotional triggers to influence public opinion at scale. It commodifies human emotions, it reduces individuals to exploitable data points, and that creates just enormous risks related to accountability.
That is a massive concern regarding implementation, I agree. But I would argue that those are regulatory challenges, not not fundamental flaws in the technology's ability to actually help people. The solution isn't to halt the development of systems that expand access to critical mental health care and make our interactions with computers more intuitive. It's to enforce safeguards. Leading EAI developers are already operating with extensive ethical frameworks and adhering to standards like GDPR and HIPAA to actively mitigate these surveillance and manipulation risks.
Compliance is non-negotiable, of course, but is it enough? I mean, is it really enough when the technology itself offers such a powerful tool for pervasive control and highly sophisticated persuasion?
When it's regulated responsibly, I believe the positive use cases demonstrably outweigh the speculative risks. Look, EAI enhances how we interact with computers, making interfaces more natural. And crucially, in mental health, clinical AI has been proven to improve equity by increasing minority referrals, often providing access where traditional resources just weren't available. If we ensure robust data protection and mandated transparency, the capacity to expand care and augment human effectiveness is, I think, undeniable. So, to summarize my position, Emotion AI is reliable and beneficial. It offers really revolutionary capabilities, especially in augmenting human workforces and expanding access to critical care. And the validated metrics, the ones that lead to medical device status and successful commercial applications, they confirm that the technology works and is beneficial when it's applied thoughtfully, creating more empathetic and efficient interactions across all the industries we've measured.
And conversely, my position is that until EAI systems can overcome these pervasive technical limitations, specifically achieving accurate emotion recognition and successful cross-cultural generalization, and until we establish much stronger regulatory oversight to address the serious risks of emotional manipulation and cultural bias, its widespread application remains fundamentally constrained. The debate isn't really over EAI's potential, but its current trustworthy readiness for mass deployment.
I think the material clearly shows that the conversation around emotional AI has to continue to evolve. It's about navigating this necessary tension between an impressive technological capability and the persistent human-centric requirements for trust and authenticity. There's definitely more to explore here.